Yeah, it's okay. A lot of people say AI.
Yeah. Okay, it's 7:05. I guess I'm going to start the meeting then. Okay. Good evening. Welcome. Tonight we will have a presentation on how to get started with Unity. This presentation was jointly developed by Remy Ai and Joseph Tomlinson. I am Alderon, Chair of Silicon Valley SIGGRAPH chapter. Before we get to tonight's presentation, let me introduce you to our organization. First, I would like to thank local Bay ACM for the use of their Zoom. Silicon Valley SIGGRAPH is one of two ACM SIGGRAPH chapters in the San Francisco Bay Area. Like our parent organization, we support professionals in the graphics field, but on the local level. Since COVID hit, we have been online. However, we typically meet in Silicon Valley companies. Although our chapter covers a wide variety of topics, we tend to focus more on the technical side of graphics. Our monthly meetings are great for learning new technologies as well as networking. One of the ways ACM SIGGRAPH supports its members is through two SIGGRAPH conferences, one in North America and the second in Asia. I want to mention that registration for SIGGRAPH is now open. SIGGRAPH is a great way to immerse yourself in computer graphics for 1 week. It's always one of my favorite events each year, and this year will be special since it's the 50th SIGGRAPH. I'm always sad when the SIGGRAPH conference ends. However, for me, as an officer in Silicon Valley SIGGRAPH, the end of SIGGRAPH conference is just the beginning, because Silicon Valley SIGGRAPH, we try to keep the excitement of the conference going all year long with our monthly meetings. Now let me introduce you to those people who make the chapter possible. I am Alderon, and I'm the chair of the chapter. Brent Simon is vice chair. Carl Anderson is treasurer. And Ken Trukowski is a member at large. I can. Finally, the next officer could be you, because we are always looking for more volunteers. So if you like what you see here, please consider joining us as a volunteer. Officer positions are voluntary. However, there are several benefits to being an officer. It's a great way to network, since you work to put together meetings for speakers. You also help organize meetings around your interests. Finally, it's always a fun group of people to work with. If what you see tonight sounds interesting, please contact us. You can contact us through our website, Meetup, our email, or we also have a YouTube channel where a lot of our meetings are recorded. If you're watching this on YouTube, the links will be in the comments. Otherwise, to find this information, you can always just go to Google and type in Silicon Valley SIGGRAPH into Google, and that will take us right to all these links later on. Okay, during the summer, we usually pause as many of us attend SIGGRAPH. However, we will start again really fresh in September. Keep an eye out on our meetup for our exciting fall lineup. I would now like to introduce tonight's speakers. Our topic for tonight is Unity Game Engine. The Unity Game Engine is a versatile and can be used to create a standalone game, uploading contents to existing Unity-based game, or easily rendering animations. Unity is also popular for those working in VR and AR. Recently, Apple announced that Unity will be supported to bring immersive apps to Apple Vision Pro. Tonight, we will have a presentation developed by two engineers with a lot of experience in Unity. Remy Ai is a silicon solution engineer at NVIDIA who's been working with Unity for several years. His past experience with Unity include the creation of the world for the VR music club Leon. Joseph Tomlinson is a game developer at Alderon Games who worked on games such as Dead Matter, Postscriptum, and Breaking Point. Presenting tonight will be Remy Ai. So please welcome Remy Ai.
Hello. Let me go ahead and share my screen.
Can you share?
Hi, could you let me know when you can see them, the slides?
Yeah, we can see them.
Great. So today we're just going to get cover some of the basics, things that you need to know in order to create Unity projects and create something that you can actually play. But about before that, about us, my name is Remy Ai. I'm a simulation solutions engineer at NVIDIA. I have been creating Unity maps for a popular social VR platform called VRChat for past 2-3 years. And more notably, I've been creating VRChat maps that are used for music events by VR Club, Music Club, Yoko. Unfortunately, Joseph wasn't able to make it today since this week was his vacation and he is out of the office, but he is a game developer at Alderon Games. Most notably, he worked on Postscriptum and a few of the new upcoming games. He worked to put the slides together and he have helped me significantly with my journey into Unity. So yeah, he's a great person. Table of content. Today we're going to talk about what is Unity for and other important informations that you need to know in order to get started in building something. So let's start with the big question. What is a game engine? The key difference between other editors like Blender and game engines are that game engines are designed to be run on runtime. So unlike Blenders where you can set up a scene and then render that scene maybe once or twice or an animation of it, game engines are designed to be interactable real time, and players can interact with objects and etc. There are more than Unity when it comes to game engines, such as there are an Unreal Engine, Source Game Engine. Think of game engines like a tool for game creators to build in an environment and assets and build environment and characters in. It is not uncommon for big game companies to develop their own game engines. For example, Crysis was made on CryEngine, which was internally developed, and Valve as well has a source game engine, which is Valve developed game engine. However, with the time on versatile game engines like Unity and Unreal Engine are proving to be very useful. So in order to get started with Unity, you will need to install a Unity Hub. Unity Hub is software to manage different versions and different installs of the Unity editor on your computer. It is highly recommended to use this Unity Hub because it makes it much easier for you to organize your projects, and most oftentimes you might need to use different Unity versions for different projects that you want to work for. And this can be downloaded from unity.com/download. Available on both Mac and Windows, I believe. Once you have the Unity Hub downloaded, let me actually pull up the Unity Hub window. It might be hard to see. You will need to install a different version of Unity Editor. Currently, I have 2019.4.31F1 installed. That's because a lot of platforms that you are trying to develop for will have different kinds of requirements. So for instance, for VR chat, that Unity version required would be 2019.4.31. And for chill out VR, that'd be 2019.4.28. And for Apple Vision OS, which you will be able to develop with the Unity as well, is going to be using Unity 2022 long-term service. Once you decide what Unity version to install, you will have to choose what render pipelines that you would like to use. Render pipelines are backend, how the game engine is rendering in the backend. Something that you have to worry about once when you're choosing what render pipelines to use. And something that will in fact impact your projects in the future, but it will be difficult to switch between pipelines. For if you're developing for platforms like VR chat or chill out VR, because the platform is already running a built-in render pipeline, you are stuck with the render pipeline, and you will have to create your project using the built-in render pipeline. Built-in render pipelines are supported on a wide variety of platforms such as Android, iOS, Windows, Mac, but it is considered quote unquote outdated by a lot of game developers because the built-in pipeline is not scriptable. On contrast, there is a scriptable render pipelines, which some of the examples of scriptable render pipelines are URP, Universal Render Pipeline, and HDRP, High Definition Render Pipeline. As the name suggests, universal render pipelines are scriptable, supported on a wide variety of platforms, and it can be configured for low performance hardware such as mobile games. And high definition render pipelines are supported on Windows, Mac, and other photorealistic renders you might want to do. For instance, if you want to use a motion capture and create a photorealistic or a scene for a CGI that looks really good, this would be a great application. And I did mention that there's the big contrast between these two is that one is non-scriptable and the other is scriptable. To elaborate on that, scriptable means that you can you can modify certain part of the render pipeline to a degree where it will fit your needs. So for instance, if you're running on low performance hardware, you can reduce heavy lifting during the runtime. Or if you are running a extremely photorealistic renders and require a lot of texture, material, polygons, then you can include scripts such as DLSS and ray tracing, RTX. These are all the features that is supported on HDRP, for instance. But most of the time, this will be mostly decided for you if you're trying to upload or create content for a platform that you want to upload it to. For instance, Apple Vision Pro might specify which render pipeline you're required to use. Once you have that set up, there are some things called Unity packages. Unity packages are basically a zip file that contains various assets such as scripts, models, materials, and SDKs. Some of the most used packages are Bakery Lightmapper, which I would get further into what that is later, and Dynamic Bones, and shaders. If you were to make your own shaders in Unity using using the shader language, and want to share that across across projects, or want to give it to someone else, you can also pack your own assets as Unity package as well by going to File and Export. So before we move on to the actual more hands-on part, is there any questions in the chat that maybe something's confusing? I think that means we're good. Oh, yeah, I think that means we're good. Okay, so this is typically how what hardware do you need for DLSS? Oh, for DLSS, depending on what type of DLSS you want to run, this is more NVIDIA specified requirements. So for DLSS 2.0, I believe you can run it on RTX 2000 series and RTX 3000 series, and the DLS 3.0 will run on RTX 4000 series. Don't quote me on that. I might be off, but that is a hardware requirement that is specified the NVIDIA. Yeah. Okay. So what we're looking at is what you will see when you open the Unity editor. Just like other programs that have little windows inside, we have little windows in Unity editor as well. Then these can be popped out into another big one, another independent window. But basically, we have File Explorer at the bottom. This is where you will be able to access your assets, such as models and materials. And on the left, you will see a hierarchy where your objects in the scene is going to be shown. And in the center is going to be the scene view, a rough render of what your scene is going to look like, and a properties tab on the right, which is going to display properties of an object or a shader, for instance. So when you start a Unity project, you would want to import objects and prefabs. It's because Unity isn't necessarily very good at making objects from scratch. There is a plugin that you can get from Unity called Pro Builder to make very, very basic objects, but they are not necessarily ideal for making complex shapes for Unity, for video games. And most oftentimes you will want to import something from another software like Blender. And prefabs are sort of like a Unity word for bundle of game objects and materials. And oftentimes FBX objects will appear as prefab. Yeah, prefabs are just bundles. It's a fancy word, but there's really nothing much to it. You can, of course, unpack the prefab to modify the content of the prefab independently. But that is that is something you can do. That is not a good practice to do so, because you can consider sort of like prefabs as one object, and then once you modify one prefab, every prefabs in the scene will be modified exactly the same way. so that reduces number of edits you have to make every time you change one thing. But if you have to unpack the prefab to do something, then I guess that's what it is. This is the interesting part, getting the mesh from the CAD to Unity, because I'm an actual engineer, an engineer who works on 3D CAD most of the time. I had came across quite I came across sorry, excuse me. I came across scenarios where I had to import the files from CAD, for instance, and most CAD software will be able to export mesh or FBX object files. However, they are oftentimes not very optimal for real-time render. Let me see if I can. I was going to find an example from Blender, but looks like that would be, yeah. So the problem with the objects exported from CAD is that oftentimes their triangles will be positioned in awkward places, and the UV maps are very broken. UV maps are basically a way for the material to say a way for the texture, which is texture is an image of the surface of the object, and UV maps are a way to map that image to the surface of the object. So setting that UV map must be done in Blender and not in Unity. Unity does not have capability to edit UV maps and objects, unfortunately. That's something that can be done in Blender. So if you work with Unity, Blender will be your best friend. Okay. Materials. This is actually something that I can just pull out a screen of Unity. So this is the Unity project that I was working on, and something that I showed just earlier in the slide. And Unity, inside Unity, you can create a material just like in Blender, and each material will use the texture as the base image and a few other image files such as normal map, metallic map, or roughness map to create a nice looking material to go on an object. This material is going to use one shader. So right here, I'm using a shader made by Mochi developer. And this material that once this done can be put onto an objects. For instance, if I click on this object in the properties, that you can see that it is using the element 0 material for that we just were looking at. And without this material, if I were to remove this material, for instance, this whole railroad is going to turn pink because it doesn't know what color of this object should be. If you import an FBX file and you have set materials in the Blender, then most likely the material settings will carry in the FBX file. But FBX files, the exported material settings from Blender will use the standard Unity shader, which is down here. This is not necessarily the best shader to use, unfortunately, because it's pretty basic, I should say. There's a lot better textures out there. For instance, for my project, for instance, I use a lot of Mochi's shader, or you can create your own shader as well. Other notable shaders are Lirton shader. They all generally make the material look a lot better, more reflective, and more natural, or more toonish, because if that's the kind of style that you're going for. And we can move on to lighting source types. Lighting sources are interesting one, because there's no inherently ray tracing capability in the built-in render pipeline. Oh, by the way, I should mention that everything that I've been mentioning ever since the showing the editor part is that this is all on Unity 2019 built-in render pipeline. So in built-in render pipeline, there's no DLSS and no ray tracing. And so there's 3 different types of lighting that can be utilized. One is real-time light. Its advantages are that it is dynamic, which means it can be turned on and off during the runtime. And it can also create runtime shadows with an object or user that is not necessarily static. Meaning that if a person or a character is running and moving in your scene, and that character is not, obviously, if it's moving, it's not static, it's going to cast the shadow because the light is real time. The downside of the real time light is that there is no global illumination. And typically there's only, there will be no bounces calculated once it has been projected to the surface of an object. So the quality of the lighting is going to be not so great. However, it is also very not performant, and using a lot of them will cause various issues with the frame rate drops. Not necessarily recommended to use in my perspective. There's another light is called baked lights. Baked lights are essentially way of computing how the light's going to interact in a scene beforehand, and then applying that as another texture to each object that is in the scene. So once you bake the light in the scene, that light is not going to exist in during the runtime anymore. Instead, each object will have a light map that is applied to show that this part of the object is lit up because there is a baked light here. The advantage of this method is that the shadow quality is going to be much higher. And it will also have global illumination because you can bake the lighting before you're actually before the runtime. And because it is just another shadow map that is applied to the object's material, it is very performant. And there can't be just only good sides. There are disadvantages. It can only affect static objects. So for instance, if an object, most of these objects around here are static and they don't plan to move anytime soon. Hopefully not, because if they do move, that'd be kind of scary. They will have a static marker checked at the top right corner here. This tells the Unity editor that this object does not have plan to move, and thus a light source can be baked onto its texture. Another niche thing that is going to happen with the baked light is because the baked lights are not present during the runtime. If a shader is going to interact with the light source during the runtime, the shader won't see this baked light source because it simply doesn't exist during the runtime once it's baked. So to solve that issue, there is something called mixed light. And mixed light is combination of both words. Some developers like to use it, some don't. And its advantages are that it can cast real-time shadow and high-quality global illumination on the static objects, basically taking the advantage from both real-time and baked light. But it's also not very performant. And the shadows that is being casted by the player or non-static object is going to be relatively low quality. Yeah, lights are cool. This scene, for instance, right now is mostly lit up by a baked light. So if I turn on the gizmos, you can see that there is a directional light source over there, and there are this light on the top of the rail that is lighting up this scene. And you can see that there is some shadow over here casted by the table. And the lighting looks great because there's a lot of global illumination. However, if I take that away, now we have everything that is real-time light, and it looks very flat because there's no global illumination. Everything is lit up by one real-time light. Yeah, so this is the kind of difference when we're talking about lighting quality, because one looks a lot better than the other, and that's mainly due to the bouncing of the lights, whether or not there is a bouncing of the lights, refractions, and global illumination. And I will take this time to mention quickly about the bakery light mapper that I briefly mentioned earlier. So important. So in Unity, there is a window for Unity Asset Store. If we would connect. And in the Unity Asset Store, you can purchase different kinds of materials, objects, not materials actually, just objects and other useful scripts that will help you with your development. And one of the top things that I recommend is the Bakery GPU mapper, light mapper. This is essentially a script that adds a plugin to the Unity editor that will use the NVIDIA optics to render the light map. Why is this necessary? Because if you go to the scene, and as you see, we have really beautiful looking light. In order to create this kind of realistic light, we need to compute each rays precisely and bounces. And the built-in lighting light mapper for Unity is using CPU for most of this process, or GPU, which is a progressive GPU light mapper. It's in preview right now. It is slightly faster than CPU, and it is definitely the best way to go if you have an AMD graphics card. But compared to the Unity's built-in light mapper, the Bakery light mapper would be way faster, and it will help your Unity game development by a significant margin. So that's the kind of thing that you can, these kind of useful scripts and objects are the things that you can import using the Unity package. Okay. And then moving on to another sort of like element is that the animations and colliders. Colliders, as the name suggests, is basically a surface that will collide with each other. Without colliders, any 3D object in Unity during runtime will basically pass through each other like Ghost. And that's typically not what you want. So you can set the colliders for each object. Let me see. So for instance, this desk here, let me turn the gizmos off. This desk here does not have a collider because I want to be able to walk through this. However, this container here will have colliders, box collider here, in order to make sure that no player will be able to walk through this this container box and follow out of the map, basically. There in the collider setting, there is a way to set this as a trigger. What this means is that if you have an object like a button that you want to add a script to use that button as a trigger to enable or disable some objects in your world, for instance, it can send that trigger signal to the script that you're going to be writing. It may sound a little weird that I included animations in this slide because in Blender, animations would be something that is completely different. There is some kind of relevance here because when you want to move an object using a script, you won't be able to simply say, okay, move this object from here to a position that XYZ you have described. Typically, you would use an animation where you set each keyframe, and at the beginning of the animation, you would have an object at a position, and at the end of the animation, you would have object in a different location. And in your script, for instance, you will trigger that animation to go to the next keyframe. Then your object will transport to that position that is in the animation. You can create animation for each object by clicking on it simply, and then going to animations and create animation. This will create something called animation controller and an animation file, which is in .anim. And you'll be able to set where this goes. So I'm creating that .anim file. This can go in assets, for instance, and I can record where this object should be. Let's say this position. Now, because I'm recording this animation, it knows that on the first keyframe, I want this table to be in this position. And then I can go to another time and set up table in a different location. And now between these animation, well, that's going way too fast. But you get the idea. Between these two keyframes, the table is moving according to this animation. So a pretty simple way to set up an animation and trigger that using script. Now I know this is like very vague so far, and there is actually a reason for that, because let me get back to this. Because the big part of the Unity is that you explore yourself and sort of like being lost all the time. There is a really good resource on Unity, Unity learn.unity.com. They have an actual course that lets you through the scripting on Unity and a lot of other stuff if you have specific questions on how to do certain things, Unity forum is definitely a great place to ask that question. I did skip this. This is a very important step, which is the last step. Once you have your scene set up with a lot of objects and that you think is ready to ship, there are three different ways of publishing and exporting. One, you could simply export using the Unity package so that other people can open it in their Unity editor and then do what they need to do. Or you can use the Unity development SDK for platforms like VRChat, Chillout VR, or Apple Vision OS. The SDK for Apple Vision OS is invite only right now, and not sure how that will go, but it will be. They did mention that you will be able to upgrade your project to Unity 2022 long-term service. Then you should be able to import the Apple Vision OS SDK and then upload it to Apple Vision OS somehow, some way. And that detail is still being figured out, I believe. Or if you just want to create something that to send your friends to and have fun, you can also create an executable by going to File and Build Settings. I guess one last thing before I move on to Q&A. Some tips and tricks. When making a VR application, consider that the player camera or the player's viewpoint will be much closer than a flat screen. For instance, this scene, if I were playing on a third-person game, these objects in the back, you will notice that the lack of detail on these trains and the payload. But when you're in VR, you're going to notice that a lot more because the player's camera is going to be a lot up closer. So that is, so basically be mindful of what you're developing for, VR, flat screen, or mobile. And this also helps if you play test on the platform that you're developing for. So if you're developing for VR, for instance, then you can actually go into the scene and then see if the little details and textures are fine up close. And then the colliders can be also checked if they are realistic enough. One of the things that great VR games, for instance, will have is a fantastic collider setup to let users really grab and interact with objects in the scene, which helps with the immersion a lot. Colliders are also important because typically when there is a bad collider to not contain the player inside a designated spot, a player might be able to find this way out of the map and fall out of the map and have all sorts of crazy things. That is something that you generally want to avoid. So making sure that a player can't escape the scene by bad colliders or a lack of colliders is also an important thing. For instance, in this scene, because this container was at an angle, a player was able to jump from the floor to the container and then escape this way. So that I had to include another collider that is basically an invisible wall to prevent a player from escaping this little contained area. So these are little few game development tips and tricks that I have. And obviously check your lighting. Lighting is what makes the scene that look flat or realistic. So lighting is very important. Now I know I went through. So that's it for what I have today. But which I think is a good time to end because we have 10 minutes to talk about any questions. I understand I went through a lot of information very fast. So
Remy, I have a question.
yeah, what's your question?
Hi, so you talked about more about creating a scene in Unity, but what about creating assets for our prefab?
Oh, that's actually a great question. If you create assets like shader, for instance, actually this is an asset that my friend made. Basically, you can open an empty Unity project and then import the FBX and materials that you need, and then create and then drag them into the hierarchy like this one. And then once you pack this into a prefab, like where you have smaller objects like this or set up, you can export that into you can export that by going to edit and see if I remember this correctly. Assets, export package. Uh-oh. Give it a second. Export package, and then you can select the specific folder in the asset folder. For in this case, that would be like this file called electro to export and uncheck everything else. Then once you give that Unity package file to someone else, that when they import the Unity package, it's going to have just that asset that you just created.
Oh, neat. Thanks, Remy.
Yeah, of course. That's the support. Hi Daniel. To answer your question, I don't actually work with game engine related field at all. I just kind of this is just one of the things I do on my after work hobby. Mostly I develop for VR chat because it's the idea of making something like a Unity world and then sharing with other people and making an avatar that best represent yourself is something great. So that's why I started. And I didn't necessarily work with or study Unity and or game development in school. So if you want to get started and this is something that you're passionate about, I'm kind of a proof that you can definitely get started and make really good Unity projects and even make indie games if 3D indie games. And I guess to fill in the gaps of what I do at NVIDIA, I'm a hardware engineer at NVIDIA. So I work more with the actual chip and the memory. Yeah, so I hope that answered your question. Oh, I also want to mention that a former Atari's coworkers workbook, book that is in about 3D game development with Unity First Edition by Frank's Lenzinier. Yeah, Carl just posted that link to that book in the Amazon. Feel free to check that out. And obviously, there's a lot of resources of how to do certain things on Unity on YouTube, the wide internet. So yeah, I think really what you need to get started on any kind of Unity project is just I can do kind of mindset, and yeah, just getting started.
I allow people to unmute themselves if they want to talk.
Hi. So I had a question on the Unity version that you were using, and is there like a free version or a trial version that you can download? And does it have to be on Windows? Can it be on Linux?
Can it be on Linux? I'm not sure about the Linux support. I do know you can download it on Mac.
Okay.
So,
but
I'm
there
not
is a
sure about
community
Linux.
version. Is that a community version, or does it have to be like a trial version?
Oh, this is Unity editor is free to download for everybody, except for if you're a big corporation with I think they specify revenue of $10,000 a year. Then you have to get licensing and stuff. But if you're just an indie developer, Unity is completely free. So you can simply download this Unity Hub from their website and just click install editor.
Right.
And yeah, install the version that you need to download.
And the scripts that you were talking about for doing the animation and all of that, that's is there like a particular language that you have to write it in? Is it or it's pretty self-explanatory?
There is a language. C# is basically the go-to language for Unity. Yeah.
Right. So that part also comes with the editor. I mean, so what all? I mean, basically, I'm just asking what all do you need to download? Is it like only the editor and maybe the?
If you install the Unity editor in the Unity Hub, it will install the Visual Studio as a part of it, and yeah, they will give you option to it would ask you if you want to install Visual Studio or not. And if you have other IDE that you like to use to edit C#, then you don't have to install it. But if you don't have other IDEs, then it will install Visual Studio, and you can actually use Visual Studio without paying too, actually. Not like Visual Studio on its own, but within Unity.
Right.
Yeah.
And what about like if you want to can you have your camera input can you have camera input into the Unity? So can I import like I have a camera or a webcam that I can use, and I guess that would be images, but mostly for 3D, for a mesh, I guess we'd need something like a 3D camera. I mean a device, a camera, 3D point that uses the point clouds. But we can import a point cloud, right? Like I know that you know, like I have an iPhone, and on that there's the reality scan. You can actually scan and it'll produce a mesh, and so I could import that mesh into Unity, right?
Yeah. If you can't import the mesh for some reason, you can always convert it in Blender.
Right.
Yeah.
And the file format that you were talking about, the FBX, that is what's that format? Is that specific to Blender? I mean to Unity?
Oh, FBX is FBX is a
A
generally
general
used,
format.
yeah, a general
Right.
format. I believe it was developed by either AutoCAD or something once a long time ago, but
Right.
yeah, it's used across the editors like Blender.
Right.
Yeah. Also, I do want to still answer your question about connecting the camera.
Yeah.
I don't know if you can connect a camera feed directly to a running instance of Unity. I'm not sure if that's a thing you can do, but I do think there will be a way to do that, because you can add a video player in Unity, and I
Right.
believe there is a way to support 3D or 2D videos. So for instance, this actually, the whole floor here is a video player, and a video player. Unity does have a built-in video player.
Right.
You can direct the video stream to a network location. Maybe that can be your local network location, and have Unity pull from that,
Right.
yeah, to project image or camera feed into the scene.
Right. So, so in the scene, there would be you can probably have a rectangle or something where it will project that's the camera images.
Yeah, exactly. It doesn't necessarily have to be rectangle either. I believe you can
Right.
be,
You
yeah.
can change. You can choose that.
Mm-hmm.
That's great. Yeah, that's wonderful. I'm looking to try out these things. So that's why I was asking about the YouTube because recording, so that I can go back to this recording and see exactly
Yeah,
what all you've done.
yeah, I'm glad you are interested in it. And Unity and Unreal Engine, they are both free to use game engines.
Right.
So feel free to experiment. Unity is a
Sure.
good place to start.
Yep.
And of course, if you have any questions, you can shoot me an email. I can try my best, but there's a lot more experts on the Unity forum,
Right.
or like there's a lot of people also uploading how to do very specific things on Unity on YouTube. So
Yep.
yeah,
Wonderful.
yeah. Good
Thanks,
luck.
Remy. Yep. Thank you.
Okay, I guess there's no more questions here, so we can wrap it up. Would you like to say a few last words before we close, Alesh?
I think I don't have any more comments to say, but I thank you very much for your presentation, Remy. That was really exciting. That was a really good presentation. Yeah, I think we all really enjoyed it. So, yeah, thanks a lot.
Yeah, thanks for having me.
Thank you, Remy.
So if there's no more questions, I guess we'll call the meeting to an end, and hopefully we'll see some of you guys at SIGGRAPH in August. Okay, going once. Any more questions? Okay, I guess that's it then. Let's call the meeting to an end then. Thanks everyone for coming. Bye.
Right. Yeah. Thank you, everyone. Have a good night.